Alright, so in this video I'm just going to quickly break down graphing linear inequalities. Now this is another fundamental Algebra 1 topic, and I know we're in Algebra 2, but I wanted to make sure that we're all on the same page with graphing linear inequalities, okay? So this should be a fairly quick video. Now once again, I'm going to be graphing all of these from slope-intercept form. Remember, slope-intercept form is y equals mx plus b. Now I know we're dealing with inequalities, but it's still set up pretty much the exact same. I still have y on one side, and then I have something times x, some number times x, that's mx, plus or minus some number, which is going to be b. Okay, so we're still going to be using slope-intercept form, regardless that it's irregardless of that it's an inequality. Okay, so let's take a look at this inequality right here. So we have y is greater than or equal to 1/2 x minus 3. Okay, so our slope is going to be 1/2. Okay, so we're going up 1 and right 2, and our y-intercept is 0, -3. Okay, so even though this is an inequality, we start this the exact same way. We plot our y-intercept and we use our slope on up 1 right 2, up 1 right 2, up 1 right 2. So I'm going to go ahead and do that, and I can go backwards, down 1 left 2, down 1 left 2, and I can kind of do that for a little while. All right, now this is where things start to get a little bit different. There's really only two differences with graphing inequalities as opposed to equations. The first difference is you got to think about if you're going to use a solid or dashed line. Okay, the first thing you got to think about is whether or not you're going to connect these points with a solid or dashed line. With an equation, we always connect it with a solid line because it's equal to. Okay, with inequalities, it's not always equal to. But in this case, it's y greater than or equal to. So whenever we have an equal to, we treat it just like a normal equation. We go ahead and we connect this with a nice solid line. So we go ahead and connect this with a nice solid line. Now if this was not or equal to, I would then connect these with a dash line. You'll see that in a different example, okay? So if it's or equal to, solid line. If it's not or equal to, dashed line. Okay, and now the second thing we have to think about is where to shade. Where does the shading go? Okay, with inequalities, we have to shade the graph because there's going to be a lot of different solutions, and it's based all on what the inequality symbol is. Okay, so when we're in slope-intercept form, so this only really works when we're already in slope-intercept form like we are. If we're in slope-intercept form and it is either greater than or equal to, we shade above the line. Okay, so if it's greater than or equal to, we shade above the line. If it's less than or equal to, we shade below the line. But in this case, it's greater than or equal to, so I'm going to go ahead and I'm shading above the line. So I'm just going to go ahead and throw some scribbles in here, kind of. But this would be a really rough sketch of our graph, and what this shading represents is where all of the solutions for this inequality lie. Okay, so if we wanted a possible solution could be a point like 1, 2. 1, 2 would be a solution. That's in the shaded region. If I plug in 1, 2 into this inequality, it's actually going to work. It's going to make it true. Point like -6, -2 would work. Point -6, -2 would work. A point like 0, 5 would work. Any point that is in the shaded region will work. Okay. Another thing is that since this is or equal to, we have a solid line. Any point on the actual line would work as well. So the point 8, 1 actually makes this work. Okay. So if it's a solid line, points on that line are going to make it work. Okay, but that's only if it's a solid line, and that's what the shading represents as well. All the possible solutions. So every single point in the shaded region is a solution to that inequality. Okay, so that's one example. I want to take a look at a different example. So let's say we had this example here. We have y less than -x plus 3. So this one's once again already in slope-intercept form. So I can go ahead and say my slope is -1, and if you want, you can put that as -1 over 1. It is down 1, right 1. Okay, so our slope is -1, so down 1, right 1, down 1, right 1, and our y-intercept is 0, 3, okay? So I go ahead and I plot my y-intercept and I use my slope. Down, one right, one down, one right, one down, one right, one. So I'm going to go ahead and plot a bunch of these points. And I can go backwards as well. Up one, left one, up one, left one, up one, left one. Now, remember there's two differences. The first one I got to think about is how I'm connecting these points. Is it a solid or dashed line? Well, in this case, this is not or equal to. So I am going to connect these with a dash line. So this is not going to be solid. This is going to be a dash line because it's not or equal to. So I'm connecting these, just making a nice dash line. Maybe not nice, but it's a dash line. So there is our nice dash line because this is not or equal to. The next thing I got to think about is where we're shading this particular graph. Okay, when we shade, we're kind of creating two half planes. Okay, so we got to think about which one we want to shade. Well, if it's greater than or equal to, we shade above. If it's less than or equal to, we shade below. If it's in slope-intercept form, this one is in slope-intercept form, and it's less than. Okay, so that means I am shading below. So all of these points below the line are going to be solutions to this particular inequality, okay? So a point like 0, 0 would actually work. A point like 0, 0 is in our shaded region, okay? And what I mean by that is if I plug in 0, 0 into this inequality, so y I'm saying is 0 less than negative x, which I'm saying is 0 plus 3. I get 0 less than, that'll be 0 plus 3, 3. This is true. 0 is less than 3, so that makes the inequality work. That's what I mean by all the points in the shaded region are a solution. They're going to make the inequality work. So 0, 0 works. Point like 2, negative 1 would work. Point like negative 7, positive 4 would work. A point that's on the line will not work because this is a dash line. It's not or equal to. So any point on the actual line is not going to work. Any point in the shaded region is going to be a solution for this one, okay? So be very careful with the solid versus dashed lines. They do have a pretty big meaning with solutions when it comes to in regards to solutions, okay? I want to just take a look at one more. And this one is not in slope-intercept form, okay? So I'm going to rewrite it off to the side so I can do some work on this. I got negative 3x minus 3y is greater than or equal to 9, okay? Well, I want to get this in slope-intercept form, so I got to get y by itself. So I'm going to move that 3x over by adding 3x to each side. So this is going to get me negative 3y is greater than or equal to 3x minus 9, okay? And now what I got to do is I got to divide each side by negative 3 because negative 3 is multiplying y. Okay, so what this is going to get me is y. And now this is where you got to be careful with inequalities. We got to be careful. Whenever we multiply or divide by a negative number, only a negative number in inequalities, we actually have to flip what the inequality symbol is. So this now becomes less than or equal to. Okay, this now becomes less than or equal to. So it's going to be y less than or equal to. 3 divided by negative 3 is negative 1. So that's going to be negative 1x. Negative 9 divided by negative 3 is positive 3. So this is actually going to be pretty much the exact same graph as the one above with just one small difference, okay? One small difference. So I'm just going to go ahead and do a really rough sketch of this one. The one small difference between these is that it is or equal to, so I'm going to be connecting these with a solid line. With a solid line. That's the only difference because this is still less than or equal to. This is still less than, so I'm still shading below. But the difference is that since it's or equal to, that needs to be a solid line, okay? So that's graphing linear inequalities. I hope that was a quick little refresher for you. In our next video, we're going to talk about graphing systems of linear inequalities, where we're going to have multiple inequalities in the exact same coordinate plane. Things get a little bit messier there, so we got to make sure that we're being very, very careful, okay? Make sure we check that out.